Hello everyone. In this video, we are going to see about paper chromatography. In this technique is a type of partition chromatography in which the substance are distributed between two liquids. That is, one is the stationary liquid and which is held in the fibers of the paper and called the stationary phase. Another is the moving liquid or developing solvent and called the moving phase. The components of the mixture to be separated migrate at different rates and appear as parts at different points on the appear. The components of the mixture to be separated migrate at different rates and appear as parts at different points on the paper. What is the principle behind in this is we are going to use two phases. One is stationary phase, another one is called it as a mobile phase, that is called as moving phase. Okay. So in this chromatography, paper is asked as a paper fiber. In paper, there is a fiber content or the cellulose fiber that is acting in the case of stationary phase, and the solvent which we are taken is called it as a moving phase under the paper. So originally, paper chromatography used to separate mixture of organic substance such as dyes and amino acids only. But now this method has been perfected to separate cations as well as anions of inorganic substance also. In this technique, a drop of the test solution is applied as a small spot on a filter paper and the spot is dried. The paper is kept in closed chamber and the edge of the filter paper is dipped into a solvent called developing solvent. As soon as the filter paper gets the liquid through its capillary access and when it reaches the spot of the test solution, the various substances are moved by solvent system at various speeds. When the solvents has moved these cations to suitable height that ranges from 15 to 18 centimeter, the paper is dried and various spots are visualized by suitable reagents called visualizing reagents. The movements of substance are relative to the solvent is expressed in terms of RF value, that is migration parameter. What they are saying is the paper what we have taken and that paper we have to put a drop of solvent into that paper. Then after that the paper should be dried. After dried paper should be kept in the closed chamber. The chamber should be saturated. After that we have to fix the paper inside the chamber. Then we have to inside the chamber, then through liquid, its capillary access, it reaches a spot of the test solutions. We have to two or more substance if it occurs in the sample solution. It moves one cation state to another anion or cation state. That should be visualized by using separate visualizing agents. Depend upon the different color region, we can easily identify what are the components present. That movements of the substance are relative to the solvent is expressed in terms of RF. That RF is nothing but retention factor. So what is the formula used for retention factor is distance traveled by solute from the origin line divided by distance traveled by the solvent from the origin line. So RF is a function of partition coefficient. It is a constant for a given substance provided the conditions of chromatographic systems are kept constant with respect to temperature, type of paper, duration and direction of development, nature and the shape and the size of the wick what we have used. That is called as radial chromatography. The amount of liquid in the reservoir humidity also calculated under RF value. So in 2 marks, they will ask define RF. So the RF defines the movement of substance. RF defines the movement of substance relative to the solvent front in a given chromatographic system. So see the images shows this is the RF system. So this is the point. We have to take the sample in this place. We have to take the paper. Inside the paper, we have to take a small drop of substance. the substance is moved from a region from this to A state, from this to B state. So this is the region. So this is the center spot of the molecule. What we are the sample we have taken, what are the colors region should be shown. So this is the solvent front, that is the saturations inside saturations. We have to, after saturation is over, the chamber should be closed with the sample of the filter paper. So inside the color durations will be carried out from this to this to this. From this regions, we can easily identify the solute of the origin line and observe the line from the distance from the solvent front. So if you calculated this two distance, we can get the RF value. The next one is Rx. So Rx is a distance traveled by the substance from the origin line, distance traveled by the standard substance X from the origin line. So this is the substance what we have taken. So this is the standard substance. Already we have known substance should be taken. So this distance are denoted by B. And what is the sample solution we have taken? So the distance should be noted. That's why they given distance traveled by the substance from the origin line as well as the standard line. So if we calculated the two difference value, we can easily identify the Rx value. So this Rx, some cases, the solvent front runs off the end of the filter paper. The movement of a substance such are expressed as Rx but not Rf. Once the solvent paper ends down, that is known as a Rx. Suppose the paper from bottom to top, that is denoted as a Rf. The next term, it is used as a Rm value. That is the Rf values of chemical related compounds are very close. So the influence of individual functional groups was presumed to be added to a rough approximation. According to Bates, Smith and Westall, Rm is defined as follows. Rm is equal to log of 1 by Rf minus 1. So the term Rm is additive and is composed of the partial Rm value of the individual functional groups or other grouping of atoms in the molecule. That is calculated by the Rm value. So there are three or four types of paper chromatographies are there. One is descending chromatography. The second one is ascending chromatography. Third one is ascending descending chromatography. The fourth one is radial paper chromatography. The first one is descending chromatography. When the development of the paper is done by allowing the solvent to travel down the paper. Descending means a bigger number to a lower number. So meanwhile, in paper chromatography, the paper what we are going to develop, it should be done by allowing the solvent, what we have taken, it should be traveled from down the paper. It is known as descending technique. The apparatus consists of a well-sealed glass tank of a suitable size and shape, which is provided with a trough for the mobile phase in the upper portion. The paper with the sample spotted is inserted with the upper end in trough containing the mobile phase, the jar itself having been equilibrated with the mobile phase prior to a elution. So this is the descending chromatography. This is the descending chromatography. From the down the paper, we have to calculate how much of solvent traveled. Okay, so this is the trough of the solvent. This is anti-spin rod. This both sides we have to adjust to remove or insert the stationary phase, that is the paper. This is the wireless fixed sites task on which trough can rest. Okay, sometimes we have to remove it and take it. It should be covered by one glass tank. Inside we have to fix the paper contains the sample. So this is the method to identify the descending chromatography. This is the advantage. The advantage of descending technique is that the development can be continued indefinitely, even though the solvents run off at the other end of the paper. So from the top to bottom or down to top, whatever it may be, the solvent should be moved from the other end also. It should be calculated fully what are the molecules should be present in the sample. The second technique is ascending chromatography. When the development of the paper is done by allowing the solvent to travel up the paper, it is known as ascending technique. So ascending means small to big. Then the sample should be from bottom to up, from bottom to up. So the samples are applied a few centimeters from the bottom edge of the paper. So we have to take a sample from the bottom edge of the paper and it should be applied a few centimeters upward. Then it should be alternately, a paper may be rolled into a cylinder form and held together by staples. It should be closed by staples or strings or plastic clips. Some other method we have to use it and close that paper. Then we have to insert the closed chamber. So both ascending, what we have seen the before technique, descending technique have been employed for separation of organic as well as inorganic substance. Both ascending method or descending method, we can easily identify organic as well as inorganic substance. But especially the ascending technique is preferred to determine the RF values of various constituents are almost same. So special case of to find it out on RF value in this ascending technique. The third method is ascending descending chromatography. It is the hybrid of the two techniques. Above the ascending and descending technique, it should be a hybrid of the two techniques. In this technique, upper part of the ascending chromatography can be folded. This will be the upper part. It should be folded over a glass rod. It is folded over a glass rod, allowing the ascending development to change over into descending after crossing the glass rod. So we have to fold the ascending development through a glass rod. At the other end should be to develop a descending after crossing the glass rod. That is the ascending descending chromatography. The fourth one is radial chromatography. The fourth method is radial chromatography. This is also known as a circular paper chromatography. The method they shows is a circular motion. So it is also called it as a circular paper chromatography. This makes use of radial development. This will make use of radial movement. In this technique, a circular filter paper is fixed. First, we have to fix a circular part of the paper is fixed in center. Then the various material to be analyzed or placed at the centers. What are the materials we have to calculate? So it should be a circular part. We have to fix it one by one. After dyeing the spot, we have to dry it and dyeing the spot. The paper is fixed horizontally on the Perti dish. On the Perti dish, processing the solvent so that the tongue or the wick of the paper dips into the solvent. So that the edge of the paper should be dipped into the dish end of the solvent. Okay, cover the paper by means of Petri dish cover. This paper should be covered by the glass plate of the dish. The solvent rises through a tongue or wick. So from this paper, the solvent should be absorbed and it comes up. When the solvent front has moved through a sufficient large distance, the components get separated in the form of concentric circular zones. Concentric circular zones. This is the concentric circular zone. So what are the methods we have, what are the components we have to identify? We have to take it in the bottom of the Petri dish and it should be closed through the tongue, and then buffer solution will be added. Then from this we can identify circular motion. Different zones should be observed. From based on that we can easily identify. So two-dimensional spectroscopy also there, but in your syllabus they didn't give the two-dimensional chromatography. So we need not to study for your exam point of view. So today's section we have seen the paper chromatography. What is paper chromatography and RF value as well as RX value, then RM value. Then what are the types of paper chromatography? Ascending chromatography, descending chromatography, ascending descending chromatography, and radial chromatography. Thank you all. We will meet in the next video. Thank you.